Hey everyone, welcome back to my channel. Today we are diving into another exciting series of physics problems focusing on static equilibrium and moments. So whether you are preparing for exams or just love exploring the wonders of physics, you are in the right place, my friend. So let's get started and unveil the mystery of forces and moments together. So the first question that we would like to answer is, what is static equilibrium? Then the second one is, what is a moment? If we say an object or a body is in a state of equilibrium, in this case static equilibrium, because there are so many types of equilibrium in science, okay? For example, there is a thermal equilibrium, which involves temperatures of bodies. Now we're talking about static equilibrium, which involves forces. So when we say an object is in a state of static equilibrium, that simply means an object is at rest, because all the forces acting on this body are balanced. So the body is not moving. For example, you can think of a book lying on a table. That book is not moving. Why? Because the force of gravity putting it downward is balanced by the upward normal reaction force from the table, by Newton's third law of motion. How about a moment? What is it? The other name for moment is torque. So torque or moment, on the other hand, is just the measure of the tendency of a force to rotate an object about a pivot or axis. So think of you pushing a door to open it. You are applying a force, right? Yeah. So the force that you are applying creates a moment that causes the door to rotate around its hinge. Let's hope that is clear. Okay, I guess I've explained it in simple terms. So for a body now to be in static equilibrium, two conditions must be met. Two conditions must be met for the body to be in equilibrium. The first condition is that the sum of all forces acting on the body must be zero. The sum of all forces acting on the body must be zero. What we mean by that is that the vector sum of all forces acting on a body in the vertical direction must be equal to 0, and the vector sum of all forces acting on a body in the horizontal direction must be equal to 0. So let's go back to our example, okay? That of a book lying on a table. So the vertical forces are the force of gravity acting downward on a book and the normal reaction force acting upwards on a book. This is provided by the table. How about the forces in the horizontal direction? Okay. If you think of this book, there is no force that is pushing it to the right, and there is no force pulling it to the left. So even the forces in the horizontal direction is equal to 0. The force in the y direction, that is also equal to 0. So these forces are resultant forces acting on the body. Then the other condition is the moment condition. So the second condition that must be met is that the sum of all moments about any point must be equal to 0. The sum of all moments or torques about any point on a body must be equal to 0. This implies the anti-clockwise moment the anti-clockwise moment or torque. Please, that's the symbol for torque. So the anti-clockwise torque must be equal to clockwise torque. These are the two conditions that are required for a body to be in static equilibrium. So in the next video, we are going to look at our first example on static equilibrium and moments. Please, you have to watch the next video on this topic. Thank you.